All right, welcome to Unit 11, Chemical Reactions. This chapter is going to be all about writing chemical reactions. So first thing we have to know is chemical reactions are composed of two things. Reactants, which are almost always on the left, and these are what are going to be doing the reacting. On the right, you'll have your products. These are what are produced during the reaction. First and foremost, when you're writing a properly balanced chemical reaction, you have to have the correct subscript. Recall from the chapter we did before the semester ended that in order to correctly balance with the subscript, you have to know the oxidation state of the atom. And that's how we balance our compounds. Don't forget about your diatomics. So for example, oxygen, when by itself, is a diatomic. So that's why we have the subscript 2 here. On this side, we have mercury 2 oxide, which has a positive 2 charge, and oxygen, which has a negative 2. That's a 1-to-1 ratio, hence no subscripts. Mercury by itself, then, is not one of the diatomics, so it does not have one of the subscripts behind it. Now, the idea is we have a chemical reaction. We cannot create nor destroy atoms. So the amount we start with on the reactant side must be equal to what we have on the product side. So once you have your subscripts balanced or written, you're going to use what's called coefficients to balance the overall reaction. Finally, then, the last thing we should do is apply states of matter. So mercury oxide, that's an ionic compound, so we'll call it a solid. Elemental mercury is a liquid, there's an L, and elemental oxygen is a gas, G for gas. This third state down here is aqueous. We symbolize that with AQ. We'll discuss that a little bit more in a couple of slides. A trick to helping to balance chemical equations is to write each element or each atom and how many of each you have below your equation on each side of the reaction. So in the example here, we have methane, CH4, reacting with oxygen, which is O2, to produce carbon dioxide plus 2 waters. On the left-hand side, we have 1 carbon. On the right-hand side, we have 1 carbon. On the left side, we have 4 hydrogens. On the right-hand side, we now have 4 hydrogens. We have added the coefficient 2. That gives us 2 times 2 H's. On the left side, we have 2 oxygens. On the right side, we have 4 oxygens. 2 from carbon dioxide, and 2, because of this coefficient 2, for water. That should give us an indication as to what we need to do on this side to balance our chemical equation. And there we go. We now have a balanced chemical equation. All right, states of matter. You're going to have to memorize your states of matter. I promise it's not as bad as you might think. First of all, the elements on the periodic table. If in doubt, always guess solid. You can take a look. When elements are by themselves, the vast majority have this green color, which means they're solid. So whenever in doubt, guess solid. There are some gases as well. First of all the noble gases are, well, they're gases. That should make sense, hopefully. The right-hand side here, noble gases are gases. Now, you won't see these happening or being involved in too many reactions, so don't stress those. But again, noble gases are gases. Some of the more common elements you'll see occurring in reactions are hydrogen, nitrogen, oxygen, fluorine, and chlorine. Those 5 are also gases. And again, you'll do well to memorize them. You're probably already familiar with the fact that hydrogen, nitrogen, and oxygen are gases. If you have any doubt about that, take a deep breath. You just inhaled a whole bunch of gaseous hydrogen, nitrogen, and oxygen. The other two you have to memorize then are fluorine and chlorine. There are two naturally occurring liquids on the periodic table, mercury and bromine. Those two are naturally occurring liquids. You'll have to memorize those. Otherwise, though, everything else is a solid. When we start bonding and writing chemical reactions with bonds in them, all ionic compounds will be solid. Again, keep in mind an ionic compound has a metal from the left side of the periodic table bonded with a nonmetal on the right side of the periodic table. So whenever you have a nonmetal bonded with a metal, you're going to have a solid compound. Now and again, in a couple of slides, we'll take a look at when those ionic compounds are in water, they oftentimes dissolve and we have what's called an aqueous compound, AQ. Most of the molecules we work with will be gases. So again, keep in mind, molecules is a term that is specific to two nonmetals. So whenever you have two nonmetals, they're almost always going to be a gas. Carbon dioxide is a gas. Nitrogen monoxide is a gas. Fluorine by itself is a gas. So most molecules we work with are going to be gases. Watch out for water. I think we should all be familiar with the fact that water is not a gas. Water is a liquid. All right, there are 5 types of reactions we're going to be working with in this chapter. The first is what we call a synthesis reaction. Synthesis means to make, so we're making something. We usually have 2 elements, sometimes a compound and an element, but it's usually going to be 2 elements, A plus B, which are going to come together to form compound AB. For example, we have 2 calcium reacting with 1 diatomic molecule of oxygen to form 2 calcium oxides. This is a synthesis reaction. We're making something. We're making calcium oxide. Here's an example. Write a balanced chemical equation for the following reaction. The synthesis of copper and sulfur to form cuprous sulfide. All right, step 1, write your formulas and make sure those subscripts are balanced. So copper plus sulfur react to form cuprous sulfide, CuS. Cuprous, from the back of our periodic tables, has a positive 1 charge. Sulfide has a -2. He's in the oxygen family, so that's a -2 charge. We're going to do what we call crossing over to make sure that our charges balance or cancel out. So the +1 is going to come down behind sulfur. We only need 1 sulfide. And the -2 will come down behind copper. We're going to need 2 cupresses to balance out that -2 charge of sulfide. We don't need to write the 1. It's considered redundant. Make sure you erase your charges. It's not proper to have those charges there. That would imply that you have ions, and we don't. We have an ionic compound, not individual ions. So if you write your charges, make sure to erase them when you're done. All right, always check for diatomics. Copper is not one of the diatomics. Sulfur, elemental sulfur, is also not one of the diatomics. So no need to write a 2 behind either of those 2. I think we're good. Third, we want to balance our chemical equation with coefficients. Okay, on the left-hand side I have 1 copper. On the right-hand side I have 2 coppers. Well, that's a pretty easy fix. If I put a coefficient 2 in front of copper, I now have 2 coppers and 2 coppers. On the left-hand side, I have 1 sulfur. On the right-hand side, I have 1 sulfur. We're balanced. We're in good shape. Finally, insert your states of matter. Copper is a metal, so elemental copper will be solid. Sulfur is a non-metal, but he's not one of our gases, and he's not one of the two liquids, so he's also solid. Cuprous sulfide is an ionic compound, solid. Now you've written your first balanced chemical equation. The second type of reaction we'll be looking at is a decomposition reaction. A decomposition reaction is pretty much the opposite of a synthesis reaction. We'll have one compound, here we have AB, and it's going to fall apart into A plus B, usually the element A plus the element B. So for example, water, H2O, decomposes into elemental hydrogen and elemental oxygen. For example, write the formula for the binary compound that decomposes to the products H2 and Br2. All right, well, they haven't told us what compound we're looking at, but I think we can figure it out. Binary means it has two elements. If it's going to decompose into H2 plus Br2, I think what we're working with is HBr. Hydrogen has a positive 1 oxidation state. Bromine has a negative 1 oxidation state. So those two will cancel out. We only need one H and one Br in that compound. Again, we're going to erase those charges. We don't want to keep them there. Hydrogen, elemental hydrogen, hydrogen by itself, is a diatomic. So we have the subscript 2 written after it. Bromine is also one of our diatomics. So it has the diatomic 2 written after it. In order to balance this, we have two hydrogens. We'll put the coefficient 2 in front of our HBr. Now we have two hydrogens on both sides. We have two bromines. So that coefficient 2 gives us two bromines. Again, we're in good shape. Finally, add your states of matter. HBr, these are two nonmetals. That makes it a molecule. We're going to call this a gas. Hydrogen, also a gas. Bromine is one of our two liquids. So we'll call this a liquid. Here's your homework for this evening. Due tomorrow.